graduation. So I will pass on the rules. Okay? So each team we will have 2 copies. So pass it around. So right now you are printing the standard sample, right? Okay. So the rule is like this. We will have a team presentation at the third day. Okay, and you need to prepare your presentation file in the morning of the third day. Okay, and make the presentation in the afternoon. And that will take 30% of your total score. And this part of score will be judged by the referees. Okay. And you need to design 2 beams. One is with the consideration of rigidity, okay, with the stiffness, okay. So first you need to design 3 beams, okay. Each team needs to design 3 beams, and you need to predict their orders, okay, of fracture rigidity to mass ratio based on their rigidity to mass ratio. Okay, so this is self-prediction part, and the other 20% of your score will be you need to compare your highest rigidity to mass ratio to the other team. Okay, so each team you will have 3 beams, right? And we will make the measurement. So you will have one with the highest value of rigidity to mass ratio, right? And then you will compare that value with other team. Is it okay? And if you rate higher, you will get more points. Okay. So that will take about 20% of your total score. And the second design, we will based on the structural failure. The consideration is based on the structural failure. So we will test the highest failure load to mass ratio. So each team will design 1 beam, and then we will test it. Okay, we will make the measurement, and the value of your highest failure load to mass ratio will be compared. Okay. So let's go into the detail. So the team presentation will be at the third day from 12:40 to 2 o'clock. Okay, and in your presentation, you need to show your design and explain why you want to design like this. Okay, your design concept, and what's your iteration process? What have you improved? Okay, and what kind of analysis have you been done on this beam structure? Okay, and it is required that you prepare your presentation file in English, but you can make your presentation either in English or Chinese. I think that part should be okay, right? And you need to prepare 8 minutes of oral presentation and 2 minutes of Q&A. And we will cut you down if you exceed 10 minutes, because we have 8 teams, right? And the time is quite limited, so we will keep on schedule. Okay? So that's 30% of your total score. And for rigidity consideration, you need to design. This is your standard sample. Your standard sample should look like this. Okay, it's required you have 2 fixture ends, and these 2 fixture ends must be in this size. You cannot modify this. If you come up here to look at our measurement station, you will see 2 fixture here, and that's fixed. So if your bin specimen cannot fit into the fixture, then you will get 0 score, 0 points. Okay? So these 2 ends must be like this. Okay? And the center part should be 160 millimeter. The length is fixed. Okay? And the size, the width, and the thickness can be varied. If you want to design your own bin, you can vary these 2 parts, this part and this part. But the maximum is like this. The maximum is like this. So if you design over this size, you will also get 0 points on certain parts. Okay, it's written in the rules, so please follow the size. Okay, so we have some limitation on the size. And for the second bin, we consider the structural failure. So the size is like this. Still, we have 2 fixture ends. Okay, the 2 fixture ends should look like this. And the center part, the length is the same, 160 millimeter. Okay, the thickness maximum is 5 millimeter, and the width is 10 millimeter. Okay, and before 7, you must print out this standard sample for the test. Okay, we will make the failure test. Okay. So, how are we going to make the measurement? So, this is our test measurement station. It's here. Okay, it's here. So, before you make the measurement, we will weight your bin. Okay, we have some scale, and they can weigh your bin. Okay, so we have the mass here. Okay, and how do we measure EI? How do we measure this bin rigidity? We will apply a fixed weight. Okay, maybe I will let one team assistant help me to show this. And let's have one beam. Okay, any beam. Okay, suppose this is the beam. Okay, and we will have certain. We will have a line here, cross this part, and carry some kind of ball here. Okay. And we will apply fixed weight. That weight will be about 1.4 something kilogram. Okay, it's a lightweight. Okay, and then we will apply it at the center of this beam. Okay, and we will measure the displacement at the quarter length part. We will measure the displacement at this position. Okay. And based on that, we will calculate EI. You can find the equation in the rule. Okay? So we will derive or calculate EI. Okay? And you could design 3 beams, and you need to kind of decide the order, the ranking of these 3 beams. Okay? So you can make whatever design you want, and you need to rank it, and then we will test it we will make the measurement and see whether you predict the correct order. Okay? And your maximum EI over M, the rigidity to mass ratio, will be compared. Okay? So this part we apply fixed weight. This part, structure failure, we will load it till it breaks. Okay, so this evening we will going to test your standard specimen. Okay, so we will get this value, standard. We'll get this standard weight carried by this beam. Okay, and this is the mass of your standard sample. Okay, and we will decide this maximum weight carried by this beam, either decide by the weight that will break your beam, or the bottom of your beam touch this line. There is a line here. Okay, because sometimes you cannot really break your beam. So we will decide that value on the maximum dispersion. Okay, the maximum dispersion is about 2 centimeters of the center part of your beam. Okay, and today we will get this value, W standard and mass standard. Okay, then you can make your own design. You can design whatever beam you want, and you need to achieve minimum of this value. Okay, so if your design beam has maximum weight reduction, at the same time your stress doesn't vary a lot, then your score will be the highest. You will get the most point. Okay? Is that okay? If you still don't know the rule, you can read through our rule and regulation paper we just passed around. Okay? So today we will make one measurement. And today's measurement is only about fracture failure. Okay? And tomorrow we will have 2 measurements, one in the morning and one in the afternoon. Okay? And for those 2 measurements, you could test on stiffness, rigidity, or both rigidity and structure failure. Tomorrow you will test 4 beams, 2 in the morning, 2 in the afternoon. Okay? And 1 each. Is it okay? So, any question or any question? So, these 2 goals are kind of different. So, somehow you need to design different kind of beams to fit for these 2 goals. Okay? So, I think it's time for dinner, right? And you can discuss your design through dinner.